So in this problem, we're asked to find the magnitude of the velocity and acceleration of the spot of the light on the wall when theta is 45 degrees. So what we have is a spotlight that's rotating, and it says it's rotating at 4 radians per second, and the light is hitting the wall, so the spotlight on the wall is moving across as the spotlight rotates. So to start this solution, what we need to do is write out the equation for the velocity and acceleration. So the velocity in polar coordinates, remember, is the rate of change of the radius, that's the velocity in the r direction, plus r times theta dot. Remember, the radius times the angular velocity equals the linear velocity, and that's happening in the theta direction. The acceleration is a little more complicated. There's two terms in the radial and two terms in the transverse direction. So it's accelerating outward at r double dot. That's just the linear acceleration in the r. And it's accelerating inward at v squared over r, the centripetal acceleration, which is also r theta dot squared. That's in the radial direction. And in the transverse direction, remember, we have the radius times the angular acceleration is the linear acceleration. And we talked about this weird Coriolis acceleration 2 r dot theta dot, where 1 r dot theta dot is coming from the velocity in the r changing direction, and the other r dot theta dot is coming from the fact that the radius is getting longer, so you're speeding up in the theta direction. But anyway, that's the equation for what's going on in the theta direction. So what we're going to need to do is find theta dot, r dot, and r double dot, and plug it into there. Okay. So let's start with theta dot and theta double dot. And so when I look at it, it says that theta dot is 4 radians per second. And it says that that's constant. So that means that theta double dot is 0. So now what we need to do is find r dot and r double dot. And so you can see from the picture, as the searchlight rotates, as the angle increases, the distance the light has to travel to hit the wall is also increasing. So there is a change in length. So there's an r dot, and there's probably an r double dot. So we're going to have to do a little bit of geometry to solve this. So I'm going to draw the picture of the triangle of the radius and theta. So there's the wall. So there's r, that's theta, and the spotlight is 100 meters away from the wall. And so let me color in the wall. So this is the wall right here. Okay. So we need a relationship between r and theta, and that way we can get r dot from theta dot. And so looking at this, I can see right away that r cosine theta equals 100 meters. So if you take the derivative of that, you get r dot cos theta plus r sine theta using the chain rule theta dot equals 0. So I just double checked, and the derivative of cosine is actually minus sine. So that should be a minus there. Okay, so let's solve that for r dot. So we have r dot cos theta equals r sine theta theta dot. And so we get r dot equals r tangent theta theta dot. We need to get rid of the r, and so r is 100 divided by cosine theta. So it's 100 tangent theta over cosine theta, theta dot. That's r dot. Next, we need to get r double dot, and I don't really feel like differentiating r dot. So what I'm going to do, I'm going to start with this, r dot cos theta minus r sine theta, theta dot equals 0. And I'm just going to take the derivative of that whole thing using a product rule and chain rule. So the derivative of r dot cos theta is r double dot cos theta plus r dot, the derivative of cos theta, which is minus sine theta, and by the chain rule, you have to add a theta dot onto that. Okay? And so now we're going to do the product rule for r sine theta, theta dot next. So as a quick reminder, when you have three things, like here, r sine theta and theta dot, when you take the derivative of a product of three things, d dt of a times b times c, that is the derivative of each one in turn, like this. That's the triple product rule. Okay, so we're going to do that, where a is r, b is sine theta, and c is theta dot. Okay, so it's minus the whole thing, so r dot sine theta, theta dot, plus r, derivative of sine theta is cos theta, and by the chain rule throw in another theta dot, okay, times theta dot, plus r sine theta, theta double dot, and that all equals to 0. So if you write everything out, you get r double dot cos theta minus r dot sine theta, theta dot, minus r dot sine theta, theta dot, minus r cos theta, theta dot squared, plus, no, minus r sine theta, theta double dot, all equals to 0. Collecting terms, r double dot times cos theta minus r dot times 2 sine theta, theta dot, minus r times cos theta, theta dot squared, plus sine theta, theta double dot, all equals 0. And then we're going to have to substitute back in for r and r dot. So r double dot cos theta minus, where r dot is 100 tangent theta over cos theta, theta dot, times 2 sine theta, theta dot, minus r, which was 100 over cos theta, times cos theta, theta dot squared, plus sine theta, theta double dot, equals 0. Now we just solve for r double dot. So putting everything on the other side and then dividing by cos theta, we get r double dot equals 100 tangent theta over cos theta squared times 2 sine theta dot squared plus 100 over cos theta squared times cos theta dot squared plus sine theta double dot. Phew! So we now have theta dot, theta double dot, r dot, and r double dot. So rather than put this all together, then plug in theta, I'm going to plug in theta's 45 degrees right now and see what everything is. Okay, so we know that theta dot is 4 radians per second. Theta double dot is 0. At theta equals 45 degrees, that's kind of nice. Cos theta is 1 over square root of 2. Sine theta is 1 over square root of 2. And tangent theta is 1. So we have that r dot is 100 tangent theta, which is 1, divided by cosine theta, which is 1 over square root of 2, times theta dot, which is 4. So that all equals to 400 times the square root of 2. Okay, there's no putting this off. We need to get r double dot. Okay, so r double dot is 2 times 100 times tangent theta, which is 1, divided by cosine squared, which is 1/2, because cosine is 1 over root 2, times sine theta, which is 1 over square root of 2, times theta dot squared, which is 4 squared, plus 100 divided by cosine squared, which is 1/2, times cosine, which is 1 over square root of 2, times theta dot squared, 4 squared, plus sine theta, 1 over square root of 2, times theta double dot, which is 0. Okay, so simplifying that, we get, if I did the math right, I get 6,400 over square root of 2 plus 3,200 over the square root of 2, which is 9,600 over the square root of 2. And making that to a proper fraction, that equals, I'm trying to get the square root out of the denominator, that equals to 4,800 times the square root of 2. So I haven't actually been looking at the solution in the book, but I think I better double check before I continue. So I'm going to double check that theta dot is 4, theta double dot is 0, r dot is 400 square root of 2, and r double dot is 4,800 square root of 2. So I just checked the example in the book, and amazingly, these are all right, but I did see that eventually I'm also going to need r. And so let me look and see what we have for r. We know that r was 100 over cos theta. That's 100 over 1 over square root of 2. So that's 100 square root 2. Okay, so we're ready to plug everything in and solve the problem. So the velocity again is r dot in the r direction plus r theta dot in the transverse direction. And plugging in, That's 400 square root 2 in the r direction plus 100 square root 2 times 4 in the theta direction. So that equals 400 square root 2 in the r direction plus 400 square root 2 in the theta direction. So they want the magnitude, so we have to do square root of 400 squared times square root of 2 squared plus 400 squared times 2 square root, and that equals 2. This is exactly 800 meters per second. Now let's just plug everything in for the acceleration. So in the radial direction, remember we have r double dot, the linear acceleration out, minus r theta dot squared, v squared over r in centripetal. That's in the radial direction. And in the transverse direction, remember we have the radius times the angular acceleration is the linear acceleration. And we have the Coriolis 2 r dot theta dot. That's all in the transverse direction. Okay, so it's plugging in the numbers. R double dot is 4,800 square root 2 minus r 100 square root 2 times theta dot squared, which is 16, plus theta double dot is 0, so r theta dot double dot is 0, plus 2 r dot, which is 400 square root 2, and theta dot, which was 4 in the transverse direction. And multiplying all that out, we get, so we end up getting 3,200 square root 2 in the radial direction plus 3,200 also square root 2 in the theta direction. And finally, the magnitude of A is the square root of 3,200 squared times 2, and there's 2 of those, so I'm just going to put times 2, and that's just going to be 3,200 times 2, which is 6,400 meters per second squared. So there you go.